Hello everyone. In this lecture, we are going to discuss the modeling and processing of data in ML. Actually, why we are going to model the data is once the data which we get, we will classify only the data which we required and we will use it. So that make us to build a machine learning model which always gives us somewhat more accurate output comparing to the other parts of the data sets. That's the reason we will also process the models and all. That part we are going to see in this video lecture. Yes, before starting the modeling concept, one thing I want to discuss is, yes, this is a machine learning process. If you observe the introduction to ML, that is nothing but the first video lecture, there we are having only three things. One is the input data, abstraction for training data, and generalization for testing data. But here it is a big concept actually. That's the reason it is known as detailed process. That's the difference. Here from input data we are going to prepare a model, and from model you are going to get some refined data. That data you are going to use for machine learning, and once the algorithm is applied you are going to get some output. So that based on that output you are going to evaluate the performance, and based on the performance for that current running part, for that current iteration you will decide whether the performance improvement is there or not. So in simple terms, performance improvement is completely dependent on performance evaluation. So, yes, before starting to this concept, the data which we are working will be in terms of strings, sentences, and also numeric thing. So that is classified into two types actually, qualitative and quantitative. In qualitative, we are have it is also called as categorical, and quantitative by the name itself you can understand it is numeric. And in qualitative, we are again having two types, nominal data, ordinal data. Ordinal data is nothing but it will be in order, something like grades or some feedback reviews like excellent, very good, good, average, poor, very poor, like that. That concept comes under ordinal data. Nominal data, you can't arrange them in order. It's just like something you are having those values. For example, student name, if you consider, uh, there is no concept of arranging, right? Yes, these persons are given first priority with this name and like that. There is no such concept. That data is comes under nominal data. And in quantitative, we are having ratio data, interval data. Ratio data is nothing but the exact values, nothing but age, salary, height, weight, and all, and marks and all. Coming to this interval data, yes, you can say now temperature is 40 to 50 degrees, 40 to 45 degrees. We will say, right, it means that we are not having the true zero, nothing but we are not having the exact value. So if we are having exact value, it is known as absolute zero value. Otherwise, no true zero value, we will call it as. Yes, data exploration is completely related to probability and statistics concept. Here we are going to discuss those that are only just enough as a basic to machine learning. We are not learning mathematics, right? We are focusing on machine learning, but mathematics is mandatory for that means probability and statistic concepts you must be aware of to understand these concepts. For central tendency, there are mean, median, mode. You know that mean is nothing but average, median is middlemost value, mode is most frequently occurring. Again, standard deviation is nothing but the square root of variance. Yes, you can see minimum value, maximum value, and this is the mean value which is exactly in middle. And here mean you are having average, right? So how you are going to calculate the variance is the difference between these xi values and the mean value squares average you are going to find as variance. On applying square root to variance gives you standard deviation. Yes, this is for median techniques and all. These all you are aware of in statistics classes. Calculating mode using mean and median. Yes, coming to the skewness is described by making use of mean, median and mode. If both all the three are in the same line, that is symmetric. And in terms of mean, median, mode order, then negatively skewed. Or mode is greater than mean, then we are going to call it as, sorry, if mode is less than mean, then it is considered to be positive, otherwise it is considered to be negative. Skewness. Now let me go to next slide. Yes, this is the variance. You can see variance and standard deviation. Here you may get out that a minus b whole square formula is a square plus b square minus 2ab, but why are we not considering in that format? The reason is, here we will ignore the proportionality constants and all, because it is completely the machine learning concept, not completely mathematics. That's the reason you can consider any of the value, anything works fine. And yes, the things in the standard deviation values, the middle exact value which is mapping towards x-axis is considered to be as mean value. Yes, the reason why we are performing data exploration is due to box plot actually. As you know, there are different types of plottings like scatter plot, histograms, bar plot, pie plots. Box plot is used to identify outliers actually. This is the box plot. First quartile, second quartile is called as median, third quartile. Here you can see, right? Yes. First quartile is for 25%. Median, nothing but second quartile is for 50%. Third quartile is for 75%. From 0 to 25%, we are going to have this minimum one, and above 75, we are going to have one level called as max level. Any values that are coming above max are considered, and below min are considered to be as outliers, nothing but we are going to ignore that data. Yes, here you can see minimum, maximum, first quartile, second quartile, third quartile. And you are going to get this minimum and maximum by knowing the IQR, that is nothing but the interquartile distance. Nothing but the difference between Q3 and Q1. Q3 minus Q1 gives you interquartile distance. And based on that you are going to, yes, as it is more greater than the third quartile, the maximum is, so you are doing Q3 plus. And since this minimum is less than Q1, you are doing Q1 minus 1.5 times of that interquartile range, nothing but Q3 minus Q1. That's the concept here. Yes, about histogram bar plot, all you are aware of. This is normal distribution, positive skewness, negative skewness. Here you can see both sides somewhat similar. And yeah, both, as I mentioned, it is regarding two, so it is called as bimodal. And if there are many ups and downs, then it is called as multimodal distribution. Yes, scatter plot for points and all. Yes, these are used for the correlation concepts. This is the positive correlation, and negative correlation will be in this format. Yes, this is the negative correlation. And if no correlation, you will be having just like points. Yes, this is the no correlation example. Yes. Now we will be having data quality issues. There will be three reasons for it. One is due to the wrong sample data, and one more is incorrect size of the data, and one more is due to some of the things which are inside the data. Those are classified as missing outliers and duplicates. And in data analysis, we are going to see how to eliminate them, how to modify them and all. Yes, in missing values, we are going to just replace with some statistical approaches. Whereas in outliers, we are going to replace with maximum and minimum values. And in duplicates, we are going to just eliminate those duplicate values. Yes, that's the things discussed here. Yes, again in data pre-processing, nothing but data processing, we will do two things. One is regarding feature engineering, and one more is related to dimensionality reduction. It can be done by making use of these three things. Actually, we are considering this principal component analysis separately as an algorithm, and I will explain more deeper regarding it. Hope you all understood, and now let me continue this one. Actually, this PCA is somewhat similar to unsupervised learning, but you can't say it as completely as unsupervised learning. Hope you understood. Yes, now you are going to see the process of modeling. In the first step, just a second. Yes, in first step, you are going to collect the data. And next, coming to the second step, you are going to explore and prepare the data. And in the third step, you are going to select a model. And then once you select, you are going to train, and then you are going to evaluate its performance. And based on that performance, evaluation can be also done. Nothing but the performance measure and performance improvement. Yes, improve model performance. Yes, for predictive models we are going to do, and for also descriptive models, nothing but for supervised and unsupervised. Yes, any input data we'll get will give about, let us consider 70 to 80% will give training data, and remove from 100% and remaining data will be given for test data. On training data, we are going to apply our model, and then we are going to give it to test data. Test data will select the accurate data which will give you the exact output, nothing but the output predictions which will give correctly only those records you are going to consider from input data and training data, and that data is stored in test data, and with test data we will predict and we will calculate the performance measure. Based on the performance measure, the model performance is going to increase or decrease. Oh, slides all are skipped, just a second. Yes, this is what it is happening. Testing set we are giving, and from the test set again it is going, sorry, from training set we are applying the ML algorithm, and it will give for testing set. Yes, here there are some of the conditions: overfitting and underfitting. Overfitting occurs due to more focusing or more overfitting on training data. Here overly we are performing for training data, so obviously testing data is going to be failed. That is known as overfitting. Underfitting is opposite to overfitting. Your model is too simple, and both training and test data there will be large errors. Here there will be, yeah, for testing data in both cases there will be many errors, but for training data here you will have less errors as you are focusing more on training data. Since here you are not focusing for training data also, you will get more errors for training data. That's the reason you can study both training and test errors are large. Resubstitution errors occurs due to train errors in training data, and generalization errors occur due to errors in testing data. And optimistic approach is nothing but both the values to be equal. These are the diagrams if you observe. Yes, this is the actual thing happening. data, some 70 to 80% goes to training and remaining goes to test. And again for training here we are going to apply some ML algorithm, and that model you are going to give for test. And here this test data will be from the original data, and model data you are going to select the correct data which will give you the correct predictions, and that data is called as testing data. Yes, k-fold cross validation is nothing but here instead of overlapping of different training and testing sets, we use multiple layers. Those layers are called here as folds. So the number of layers or the number of folds is nothing but k. That's the reason it is called as k-fold cross validation. Here you can see, right, data is split into k subsets, and individually you are going to perform training and testing on them. That's the meaning here. Yes, you can see overfitting, underfitting. Yes, from here you can see again the statistical terms, bias and variance and all. Variance, as you know, by squaring all the terms and subtracting it with the square of the mean value, you are going to get variance. Or instead of squaring, simply if you are performing the difference of the prediction value and the actual value, that's the that concept is known as bias. And bias and variance are inversely proportional. So here you can see the differences. In overfitting, it is too complex, and underfitting is too simple. It occurs due to high bias and low variance. It is due to low bias and high variance. Inverse proportionality. And I told in overfitting, since we are providing the overfitting to training data, there will be low errors for training and high errors for testing. And in underfitting, since the model is too simple, you are also going to get high errors for training data. For testing data, always there will be high errors in both the overfitting and underfitting conditions. Now, this concept is completely related to this confusion matrix. Here you can see, right, actual you will take on as columns and predicted ones you will take as rows. If actual predicted both are true, it is known as true positive. If actual true but predicted loss, it is known as false negative. Actual loss predicted win is false positive. Actual loss predicted also false, nothing but condition true, so it is called true negative. Here you can read the theory part. Yes, you will we will use this confusion matrix to calculate the yes to evaluate model, and you can evaluate a model in various techniques like precision, recall, F measure, accuracy, error rates, sensitivity, specificity, and kappa and all. But the reason why we avoid this accuracy and error rate are you will get for error rate always low values and accuracy rate always it will be high. So you will think that model is working fine. So that's the reason you are going to use precision and recall concept, where precision is nothing but true positive by true positive plus false negative. Sorry, true positive plus false positive. If true positive plus false negative, it will become recall as well as sensitivity. Here you can see, right? It is nothing but the both actual and prediction to be correct. For winning only we are doing. So true positive by complete prediction of winning. 85 plus 4. Yes, this is the pressure. And recall is with respect to complete actual thing you are doing. So 85 plus 2 here you will get. F measure is calculated as 2 into pressure into recall by pressure plus recall. Now coming to accuracy. Accuracy is nothing but with true values you are going to perform. Nothing but true positive plus true negative by whole thing. So 85 plus 9 by complete sum is 100. 94 by 100. 1 minus model accuracy gives you error rate, or 1 minus error rate gives you model accuracy. Remember that one. Error rate will do with respect to false values, nothing but false positive plus false negative by complete. So 2 plus 4 by 100. That gives you error rate, and the sum of error rate in terms of percentage and accuracy in terms of percentage gives you 100%. Or if simply you will say accuracy plus error rate equals to 1, you can say. Sensitivity, yes, sensitivity is similar to recall. So let me discuss specificity. Specificity is actually completely opposite to recall. Instead of positive, we will consider negative. Then we have done with respect to the win, right? Here you will do with respect to loss. True negative by true negative plus false positive. That gives you specificity. These are the evaluation techniques, and one more important technique is kappa model. And kappa values ranges in terms of probability like 0 to 1. 1 means perfect and 0 means there is no agreement at all. Nothing but completely it is waste, you can say. P of A minus P of E by 1 minus P of E is the formula where E is for expected agreements and A is nothing but the agreed or accepted agreements or observed agreements, you can say. Yes, how you are going to calculate is P of A and P of E are needed. P of A simply 2 positive plus 2 negative by whole thing. It is nothing but accuracy, you can say. Probable, yeah, accuracy is nothing but P of A. That's the meaning. Now, how you are going to perform P of E? Firstly, for positive instances and positive predictions. What are positive instances? Instances you are saying, not predictions. Predictions means you will take this line. 85 plus 4 by, yeah, whole thing should be 100, nothing but sum of all the values. Based on your sum of all the values, you can consider denominator. Yes. For predictions, we will take like this, and for instance, you will consider like this. So here you can see 85 plus 2, 87 by 100, and for prediction 85 plus 4 by 100. Now similarly for negative instances 9 plus 4 by 100. Yes. For negative predictions 9 plus 2 by 100. You will get all these things, right? Multiply the prediction and instances for positive separately and negative separately. Then add those both, you are going to get P of E. Substitute in the answer. You will in the kappa formula P of A minus P of E by 1 minus P of E. You are going to get the answer. And that answer is going to say your model whether it is excellent or not. Yes, this is the complete theoretical part regarding it. Yes, this similarity width and sum of squared error, sum of squares total and all, it is completely regarding the probability concept. Probability and statistics, there you can study. R square equal to SST minus SSE by SST and all. Yes, with this modeling and processing of data in ML is covered. And in the next lecture, we are going to see the feature engineering in machine learning. Hope you all understood. If you are facing any doubts, drop in the comment section. Thank you.